For many years, optical computing was mostly a research project that was far from being commercially deployed. But recently, everyone in the semiconductor industry has been talking about photonics. So, what happened? Did the laws of physics suddenly change? From a physics perspective, light has always been as good as it gets. It travels long distances with very little loss, and multiple wavelengths can carry data simultaneously through the same optical fiber. That's why nearly all high speed communication today relies on fiber optics. But computing isn't that simple. A computer also needs memory, control logic, and the ability to manipulate state. Things that transistors have become incredibly good at over the years. But light just hasn't. There is another problem. Unlike transistors, optical components can't keep shrinking every generation because their size is tied to the wavelength of light. That has made photonic chips much larger and hence less practical than electronic ones. But then something big happened, not in photonics, but instead in computing. As data centers grew larger, moving data between the CPUs, GPUs, and accelerators became just as important, if not more, than the computations itself. And that's exactly where photonics shines. Optical interconnects deliver far more bandwidth using much less energy. And at a data center scale, a slightly larger chip is a small price to pay. This has given manufacturing giants like TSMC a compelling reason to invest in silicon photonics today. But in my opinion, optical interconnects are just the entry point, especially if semiconductor manufacturers can continue the same mass manufacturing expertise they've shown with transistors over the years. We are already seeing startups building optical AI accelerators that perform matrix multiplications using light instead of electrons. And that's just the start of it. If optical memory is solved and manufacturing reaches scale, we might one day live in a world where all computing happens without electrons. Imagine that.